Hi, Mark. We're super excited to have you today, and I prepared a quick introduction. So, Marc Van Peteghem is a world-renowned, and correct me if I'm saying your last name wrong.
Fine.
Van Peteghem?
Yeah.
Okay. Is a world-renowned naval architect, and which is great for the theme of our semester. After studying naval architecture in the UK, he founded the Naval Architecture Agency, VPLP, along with his friend and colleague, Vincent Lauriot-Prévost. And together they both specialize in racing multihulls design and became quite famous in their own right. Their boats have actually won many races, including the 2010 America's Cup, which has put the duo at the forefront of naval architecture worldwide. Marc has also designed two of the largest cruising catamarans in the world, which is certainly added to their impressive repertoire. And perhaps even more impressive, Marc has created, along with Yves Marre, Alain, Connan, and Gerald, Similowski, to create the NGO Watever in France, which assists underprivileged populations living along the shores of oceans and rivers, which is great because, again, I think many of us are quite interested in that for this semester. And he's now president of the NGO. And on top of that, he has co-founded the Sustainable Design School in order to further the conversation around our maritime ecosystem, sustainability, the environment, and design's role within it. So we're really happy to welcome you today.
Thank you very much. I'm very happy too. So I'm going to try to share my screen. A little index. So I will start by the presentation of the company. Then I will go through some projects which address my deep concern about sustainability, which I managed to, or we managed to include in our work. I will take you for a trip in Bangladesh and to look at the diversity of the vernacular architecture there, which is, I think, very inspiring in frame of the project we will do together. And some basic physics about yacht, well, boat balance under sail and resistance. And then we'll talk about the project, which is not part of this presentation, really. I just put the text. So VPLP was founded by Vincent Lauriot-Prévost and myself. In fact, we were college mates in England like 40 years ago, and a little bit more now, 45 years ago. And we, of course, we were very good friends, and we decided maybe it would be nice to do something together. So it's kind of a dream after 3 years working for a different firm. Each of us, I mean, with different people. I had the opportunity to design a first boat, so we gathered together and start to design our first boat, and that's how the company was launched in February 1983. Today, it's a firm of 35 collaborators, including naval architects, designers, and engineers. I guess it's one of the largest one in the world. And one particularity is we are really interested, and we're really developing all sorts of different projects. I mean, it could be anything from a little beach catamaran to a cargo ship of 121 meter, but including you will see cruising and racing catamarans and monohull and any subjects. If we feel it because it's bringing something, and it's very important too, if we feel well with the people who are carrying the project, and then we might be interested to do the project. Some basic values which are very important. Maybe it's not the first in the list, but it's probably the first. I think the more important is listening to people, listening to our client, listening to each other. Listening is very important because when you do something wrong in architecture, you do it in the first moment. It's because you misunderstand something, or you think wrong at the first time because you didn't listen enough, and you didn't take time to reformulate maybe the question. So listening is very important. Of course, innovation and creativity, that's out of saying. Empathy is really, really important too. And of course, the sea is such a harsh element that, and it's very, very difficult to really foresee what's going to happen, So we learn that humility is very, very important. As the company grew, we started. We had the chance to start doing a racing multi-hull and a racing and a cruising catamaran at the same time. And the catamaran was the first model of a big brand which is called Lagoon, the biggest brand in the world, and so we that's very important because we got paid in royalty for the cruising catamaran, and we have invested everything, almost everything, in racing and in increasing our knowledge to become better in tool and in people. And now we have engineers which are developing their own tool if they don't find the one which is convenient on the market. Since 2000, I really got struck by the necessity of by the awareness of the importance of the climate change and all what was going to happen if we don't find solutions. So the main domains of activity, we will see that a little bit later on. It's racing, recreational, as I said, and maritime, shipping. We have 3 sites, one in Paris, one in Vannes, in Morbihan, in Brittany, and one in Nantes. Now I change site. This is part of the team. Not everybody is there, but it's a team of young people.
It doesn't seem to be showing up.
This is the Van studio. It's a wooden building. It's part of the team. Some consideration on what happened in the last 40 years. It's a little bit I'm not that old, but just to let you know, when we started, the naval architect was yacht naval architect was supposed to cover all the aspects of the design. We were taught to do everything, all the calculations, structure, hydro and aero calculation by hand, and everything, and to fair a shape, to fair a hull. It was with a spline and weights to hold the spline, to be sure to have a fair line. And you could spend maybe a week trying to fair a hull, and then to do all the calculation and realize that the calculation were not good, so you restart and so on. It was really long, and at the same time, you know, I sailed myself quite a lot too. We were navigating with a sextant, and so that was really another time. I like this sentence from Enzo Ferrari, who said, "Teamwork has replaced the solitary genius." So, of course, like probably any transport vehicle industries, everything has changed because it's both a very technical subject, but also a very a subject which is really linked to people. So it's very important to really understand both, you know, like deeply how people live, what they want, what they do, and also to be as good as you can, technically speaking. Of course, the digital revolution has, you know, brought a lot of new methods, 3D modelizations, actual measures on board, you know, which we had no real ideas of the loads before, until you realize something has broke. You couldn't really know what are the loads, and of course all the design tool and numerical simulation. Just to give you an idea, on the past 20 years, the speed of the racing sailing sailboat has doubled. So just the 20 last years. And of course, all that has really changed our relationship with yards. Now we are supposed to bring a lot more information, plans, and accuracy to yards. So I was talking about cruising catamaran, the lagoon range. The first one is the one with a pink spinnaker, and the 42 on the bottom is not the last one, but it's one of the last one. Since this one, in the first one, where you could hardly have a headroom because the coach roof was really you know, sloppy and really low. So to have a good look, because at that time people say, okay, catamarans are very comfortable, very stable, they are fast, it's great, but this is not a boat, it's horrible. So we did our best to make catamarans look like a monohull. And as you can see, over the years, people have, in a sense, accepted that the comfort was something important, and now there's no question, no compromise in comfort. You could also notice that the windows were sloppy at that time, but because it was nice, of course, better looking, extra. but in fact, with the sun, it transformed inside the boat of a greenhouse effect is terrible, and also you lose some space. So we came to the kind of evidence that if the windows were vertical, we would have less greenhouse effect, and we will maximize the space inside. We did also over the time a very large lagoon. This one is 24. Those one is 24 meters. They exist in two different modes. One is sailing mode, and the other one is powerboat. It's not exactly the same hull, of course, because the hydrodynamic is not the same, but it's a sail footprint, the same space, the same accommodation. And as you can see now, there is a real, what we call a fly bridge, a space outside on the top, which is very, you have a view of that on the top right, which is a very nice place to be. But, they're really a little condominium on water. And just to give you an idea, we recently passed this 6,000 boat produced by Lagoon since 1987. Another brand, which is called Outremer. Outremer, it's another, Outremer, there are catamarans made for really traveling around the world with a family. They're fast, not extremely fast, but fast enough. Performance. We always talk, very often talk about performance. For me, performance is to be able to sail at 6 knots with 6 knots of wind. So in a very little breeze, you don't start the engine. You are able to do reasonable speed under sail, and this is performance. Top speed is one thing, but for me, a good boat is a boat which has good sailing abilities, enough to be able to sail with a little wind. We did a lot of studies, and we're still doing a lot of studies about that. For instance, in the Mediterranean, in the Med, if you are able to sail from 6 knots of wind, real little breeze, you will, during a summer, you will only use your engine 15% of the time. If you need 10, 12 knots of wind to be able to sail with a reasonable performance at a reasonable speed, then you will use your engine 70% of the time, because in summer the breeze is really light. So that's something very important for me. And if you are able to do that, then you can think, and we are doing a lot of studies about that, you can think to be able to design a zero emission boat, because with some solar panels, like the one maybe you can see on the left, on the right picture, there are solar panels on the top, on the roof of this boat, and with the solar panels here, you're able to have enough energy for fridge, navigation, light, and so on. And if you don't need a lot for the propulsion because you are able to sail with the wind, then you're good, and it's possible to do so, to do a zero emission catamaran. The same group who's doing Outremer is doing gunboat. Gunboat, they are really fast, high-tech, top-end catamaran. full carbon, full extremely light, extremely light. And as you can see, they're able to lift the float out of the water, and but they still have cabins and you know, all the comfort inside. You know, because if you want a light boat, yeah, performance is about the weight. You have to be light. There is no other solution. You can be light, being, you know, frugal, and say I don't need a lot of things. I really like simplicity, almost, you know, Spartan life. And then you have a light boat, even if it's not very sophisticated. Or if you want everything, all the comfort, then you need to go to carbon construction and very expensive technologies. That's gunboat, for instance, and then it's very expensive. There are three things you can't have at the same time. It's speed, comfort, and budget. You have to choose two of the three. You can't have the three together. Some yachts, we did some yachts. We did starting from here. Koyonen is 24 meter long. This one is 28. Cilium. This one is Hemisphere. Hemisphere is probably I'm sure it's the largest. Those two, in fact, are the two largest sailing catamaran. 44 meter and 42 meter. Douce France here has been launched in 1988, so quite a long time ago now. Still cruising very well. And this one is 33 meter long. It's called Mousetrap. Those two ones are in aluminium, just to let you know. Because at a certain size, there's it's not really worth going to composite. What you're going to save compared to the price, the increase in price is not really interesting. But underneath, you know, 33 meter, 24, and 28 meter, all those three ones are composite. Racing. This one is our first trimaran, 1983. And here you have already foils here. I don't know if you're familiar with that, but foils are like underwater wings, exactly like the wings. With the speed, it gives you lift, and then you lift the boat out of the water. For instance, here the hydropter is a fully foil-borne machine. It doesn't touch the water anymore. The hull doesn't touch the water anymore. Just the two wings here, and a T wing, which is at the back of the main hull here. This one is foil assisted. You see the L-shaped foil here. And you see almost all the weight of the boat is on the windward float here, but the float doesn't dig into the water because in fact it's the foil which is under the water, which is taking the weight. So you reduce the surface of the hull in contact with the water, so you reduce the resistance. And this one is one of the nicest moments in my life. It's when Florence Artaud, French woman sailor, won the Route du Rhum, which is a single-handed race across Atlantic from Saint-Malo to Pointe-à-Pitre. and she won. And Florence was we were made when you know, she started to studies to become a doctor, and I started my studies in England. And she said, "Well, I'm going to stop my studies and start sailing and racing because I want to become a sailor." And I said, "Well, I'm starting my studies to become a naval architect." And at the end, we had the chance to design this beautiful boat, and she won. And she won the race, and that's a dream story which I really wish you to live, because it's unfortunately she died in a helicopter crash, and I was very, very sad, still very sad. On the right you have Oracle, 110 feet trimaran who we designed, who won the America's Cup. And maybe it's something I will tell you more about. Just look at the strange rig here. It's not a normal rig with a mainsail and a jib. It's a wing. It's a wing like an airplane wing. And she won the race. She won the America's Cup with this ring, and that gave me some ideas. That was 2010. Some racing monohull. You see now they all are foils, because of course you minimize the resistance to motion in water if you manage to lift the boat above water, and that's what they do. So Gerald Safran, this boat under another name won the last Vendée Globe. I don't know if you've heard about this race. Gerald, and that's another picture of Gerald. You see that they're jumping really above water. Yeah. So at a certain, as I said, you know, I start to become really anxious and aware. I'm saying, well, we've been very lucky. We had a lot of nice clients, nice sponsors. We have a nice team. We have a lot of knowledge. What can we do to help? And looking at, I will tell you more about the wings, but we started to think if we could. The wings are, you know, they're stable in shape because it's a volume. It's not like just a membrane, and so you can calculate the performance. You can calculate the lift. You can calculate the drag. If you can do so, then you can automatize the behavior, and you can say. You can really trim the wing the way you want. And I said, okay, if we can do that, and maybe if we are also able to refit and to be able to retrieve, you know, completely the wing, maybe it's a good solution to hybrid, maybe not replace totally, but hybrid the propulsion of ships. And at the same time, we heard that Ariane Group was reconsidering the contract for the transport of the elements of Ariane rocket from the European port to Kourou in Guyana, French Guyana. And so they were looking for a new transport contract. And so we we designed this boat on the left really fit to the special constraint of this really special transportation, and we designed a boat really for that purpose, with 4 wings, allowing to save up to 30% of the fuel and therefore the emission. And we give this project to ship owner who take part in the contest, in the offer to do this transplantation, and he won the contest. And so actually the boat, this ship is under construction. She will be launched by the end of 2022, and we start a new company to produce, develop, and sell the wings. I will tell you a little bit more about it, sorry. And on the right, you've seen all the pictures of a boat flying and on foils. And we thought that maybe if we could develop a fast ferry on foils, it could be very advantageous, because in that case, going fast makes a competition to airplane, small airplane, to the inter-island transportation, between, for instance, the Greek islands or the west coast of Norway, or any island in Pacific, which distance are long, and it's taking a long time with a ferry, and also people are sick, and so as an alternative, if you could, we are designing this boat at the moment, and with the foils you can really damp all the motions, as the boat's not touching the water. She's really flying, and then you don't feel any wave motion anymore, so it's much more comfortable, and it consumes half of what would consume the same boat if she was waterborne, without the foils. So it's a gain in energy and in emission, and it's also more comfortable. So we're trying to develop this to see if there is any attraction about it. Going back to the wing, we thought maybe if we could make it fully automated, because of course, ship owner or shipping company don't want to have an additional crew to look after this kind of system. It has to be fully automated. So it's okay, maybe we can do that. We can adjust the camber and the twist. Well, twist is not fundamental for shipping, but playing with the camber, which means the second element, the angle of the second element to the first element, that gives you power, and to be able to reef and to furl it is very important also in port and in extreme weather. Maybe I didn't explain, but there are 2 elements and a little slot in the middle. In fact, the air the air through this little the little gap between the 2 elements accelerates and adjusts the flow on the outside of the profile. And so if you compare the plan view of this and of a normal rig, this is twice, almost twice more efficient than a normal sailing rig. And we have developed also a little software which deal with the automation and all the different configuration. For instance, if you have too much heel and you don't want to heel more because of any reason, you can have that in the software, which will depower, decamber the wings or reduce the angle of incidence, and so the heel will be automatically trimmed to a value. And in fact, well, this is important, and we developed a little prototype that we fit on this little trimaran, and strangely enough, it worked. It worked almost at the first time, and so then we in 2018 we rigged 2 wings a little bit bigger than that. Those are 32 square meter, still small ones, and on this very special boat. This boat is Energy Observer. She's a catamaran covered, of course, as you can see, with solar panels, and she is a really zero emission boat. She has hydrogen and fuel cells, solar, batteries, of course, and the wings. When there are small wings compared to the length of the boat. The boat is 32 meters long, so we didn't try to make her becoming a sailing vessel, because that would have been cheating. It's the wings that are small because we wanted to keep the same proportion as what could be a vessel of the future in several years, propelled with wind, solar, and hydrogen. So we try to keep the same proportion. And in fact, when the wind is strong enough, she is only going with the cells, and she can regenerate with an hydro generator, some generator which has a propeller, and with the speed of the boat, we are producing electricity. And when the batteries are fully charged, then the excess of energy is used to create hydrogen with an I don't know the English term of that, but electrolyzer. Electrolyzer, maybe I'll try, and then the hydrogen is compressed in bottles in big reservoir and used after when the wind goes down. Maybe and if there's, then they use the electricity which is in the battery, and when this electricity is gone, then they use hydrogen through a fuel cell to produce electricity. So she went to Spitzberg, then back to France, and she crossed the Atlantic. She has passed Panama Canal. She's in the Galapagos, and she will be in Tokyo for the Olympic game in Japan in July, sorry. And again, Canopy, this project for Iron, which I already talked about. And so we founded a new company called Aero, A-Y-R-O, which is really only dealing with the wing development and industrialization. and we are talking to, so when I said, we're doing all sorts of different things, we are talking now with ship owners and people like that, which is really a totally different world. I'm not, so I'm, of course, now in the company, there are people who really know how to deal with this kind of problem, which is I had the idea, I developed the idea, but then I'm totally unable to run an industrial company of this size. Then I will take you to Bangladesh, because as in 2005, Yves Marre came to my office and he said, I'm living in Bangladesh. I used to be an Air France steward, and when I flew several times above Bangladesh, and I saw on the top right picture the flood during the monsoon, and I thought I have to do something. So at that time, that was when was that? It was 1990, I think, something like that. Decision has been taken to scrap the river barge because there were too many river barge in France. So he managed to get one for 1 franc at that time, or €1, no, 1 franc, sure. And in fact, he sailed from south of France to Bangladesh with the river barge through Suez Canal, and then he arrived in Bangladesh. He got married with Runa, and together they transformed the river barge in an hospital, which is called Friendship Hospital, and they founded an NGO called Friendship. Later on, then Yves told me, the hospital is on the bank of I don't know if you know the geography of this place, but Bangladesh is crossed by 2 really big, one of the biggest river. One is Brahmaputra, which is taking all the water, all the snow melt of the north face of Himalaya, and the Ganges, which is taking the south part of it. Both rivers meet in Bangladesh, and there is another, sorry, there is another river called La Meghna, and those really big river made one of the biggest mangrove in the world. And people are, of course, really, really poor. Bangladesh is a quarter of France, and I think now it's over 270 million people on this territory. And as you can see on the picture, I think 25–30% of the territory is become flooded every year for the monsoon, and the bank is collapsing, and so people who live close to the bank have to move and rebuild their house all the time. So those totally underprivileged people, there is no road, there is nothing. So to bring care and some medical assistance was very important. And Yves told me, when the river is moored somewhere, the barge is moored somewhere, we need to have a fast boat with very shallow draft bring people to the hospital. So he asked me if we could design. In fact, he said maybe you have a float of a trimaran, something like that, and I can manage to do something myself. And I said, no. I'm going to be involved in your project, and we designed this ambulance that you can see on the top right of the screen, and we co-founded together an NGO called Watever, which is a contraction of water and ever. There is no H, and we a little yard was built on the river side, and we built 3 of those ambulances here. I will show you, different pictures of. I've been really touched by the all the different boats I have seen in this country. They are of course really poor, and you can imagine that nothing is left for on purpose, or I mean, it's really everything is as a meaning, as a usage, and the shape. I remember looking at the river, at boat, passing by on the river, and I was doing my work on the reversely. I mean, when you have a client brief, you listen to the brief, and then you design something which will be in accordance to what the client will wants. And then when you look at a boat in Bangladesh, you could ask yourself why the ends are like that, why is the shape like that, and try to find why, because there is nothing really free. I mean, it's always for a purpose. For instance, the moon boat here, it was during the winter, in the dry season, in this beach, and there were hundreds of those boats, and I was really wondering why. And then I look at Google Earth, and I tried, because I really wanted to find out, because there was nobody on the beach, we couldn't ask, and so I was wondering really why. But in fact, there's in summer there's a big wave which is formed here about 300 meters away from the shore, and after that it's a kind of lagoon, and so those boats have to go through these big waves to go out, and on the coming back also they have to pass these big waves. And I managed to sail on this boat a year after, because I really wanted to experience that, to fully understand why is this shape, and it works perfectly, absolutely perfectly. And the fact that the bottom of the hull is not flat but rounded, having passed that wave, it is a very shallow water, but with this shape, the boat never gets stuck by the sand, and it's just incredible. It is just perfect. There is also, we'll see on different pictures, there are different. This is a typical riverboat. The construction of this boat is made with staples, and they build the skin, which is the planks are stapled to each other, and it's brought together against to the shape using ropes and bamboo, and it's when the shape is okay, then they build a structure in it. It's the other way around. Whereas we'll see some other boat later on, but you will see this one, for instance, which is a fishing boat. It's a champagne. It's a construction which is derived from the Chinese, like this one, for instance, which is quite traditional, with planks like that and nails like that. This is a boat that we built in the yard, and it's not a wooden boat. It's a boat which is built in jute fiber and resin, because we tried to see if we could. The problem in Bangladesh is because there's so many people. There is no wood. There is no good wood anymore, and it's the same in all over the place. The same in Africa too, and that's one of my. We will talk about that later on. One of the passion I have for bamboo, because I think it's a good way maybe to solve this problem. So now the boats are made with wood which is not as durable as it was before, and they have to repair it very often. So we say, why not try to, because Bangladesh is maybe, I think, the first or maybe the second with India, I don't know, producer of jute fiber, of jute, and jute fiber is not used anymore in Western countries, and so I saw factories with really hectares of machine, and nobody anymore to make cloths, to make rug, to make and all kind of thing, but really slow, very slow activity. And we said, maybe if we could make a good technical woven, maybe we will be able to replace glass fiber cloth by fiber. What we did, it worked quite well. And this picture, I like that very much. You know, that's very much Bengali. On the beaches, you can find you know, a lot of polystyrene floating and or on the beach. And so the kids there, they're collecting all the polystyrene bits they can, you know, they can find. They fill plastic bags with polystyrene bits, and then they build this quite transparent structure in bamboo, just to give a shape to the polystyrene bags, and then they tie everything together, and they go fishing 2, 3, 4 miles away from the coast. I love this picture. Some more moonboats, as I said. You can see a little bit of the wave here, but it's still in winter and the dry season. It's much higher in summer. Typically, those boats are used to go like 2, 3, 4 days, maybe a week at most away for fishing, because after that they don't have enough preservation capability for their catch. You can see here, you know, they find it's a return from of the fishing boats, and here it's a champagne. It's a fishing boat that goes offshore 3 weeks, 3 weeks. They take ice. They take a lot of ice and they preserve their catch like that. But very often they sell the best pieces. They sell it to foreign to foreign country boats, which they cross in the middle of the Bay of Bengal. Everybody is fishing there because there are a lot of fish. Some more traditional boat, of course, you can find 50 years ago. There was no steel, no engine, so it was still like that. And now it's, of course, much more. The big boats are in steel and they have petrol engine, but you still have a lot of construction like that. This is a racing boat. I think she can take like 40 people rowing. This is the simplest boat, just a log which has been carved. I don't know, this is called an épervier in French, I don't know, but very, very unstable little boat, and they go fishing with that. This is very interesting. It's a bamboo structure, and which is used to roll a little bit the fish to be able to replace a plank or to take care of the hull. And it's even a very, very heavy fish like that, with they just tied some ropes to the boat, and slowly, they're using the bamboo to be able to roll a little bit the fish. It's incredible. Some bamboo structure, which I like. I don't know, it's just like that. And this is all those little boats. They are called the Bohemian. They live on their boat, which is not much more bigger than this one here, for instance, with just a little cover, and they gather like that, like a flower. And this is in middle of Dhaka, the capital. Block of ice to be loaded on the fishing boat here, and several boat constructors, this is typically what I said. The Bohemian boats are like that. They can carry, they live on board, and they do all sort of all kind of transportation. If needed, people or any cargo, they can. And very often you cross that kind of a bamboo raft. Even people they leave. They can they leave the north part of the country, close to the mountain, and they go down to Dhaka, and even north, south. So it takes real time, maybe a week or. So they live on their bamboo raft, and then they deliver the bamboos. That's the modern, if I say, ships are in steel and with engine, and yeah, when you talk to them as fully loaded, is fully loaded. I mean, if there is a little wave, the boat would sink. They're loaded to the gunwale, you know, really to the maximum. And those boats are in steel, and this one is an old little boat, which I like, so put it in the presentation. Well, that's about Bangladesh. I mean, I could really talk about those people and boats, because they live by the water. Could it be by the river or in Chittagong by the sea? It's the same. They have a relationship to water, which is incredible. Even so, they can't swim very often. And also, people are smiling. You know, I went there maybe 10 times or so, and I think I learned more by receiving smile and doing things with people. That what I could bring to them. Really, it's still and it's becoming difficult to go there because of problem. But we still have a small team on place. Maybe some physics. That's maybe halfway from my presentation and the workshop, just because it's the pictures are fresh. When the wind is blowing, so there's a force applied to the sail, which can be spread into a driving force and some force, lateral force here, and those two, and the keel here, or the centerboard, or maybe just the hull, will develop force, which lateral force, which is opposed to this one. This is the resistance, and we'll talk about on the next slide. We'll tell you a little bit more about that, which is equal to the driving force. So the boat accelerate until the resistance become equal to the driving force. And stability. Stability, well, the center of the volume here, it's called center of buoyancy. That's where the Archimedes force is applied, and the weight here balance the inclining force due to the wind. Resistance, sorry for that, it's maybe a little bit technical, but just for you to understand what I said about performance. This is globally speed, but it's a little bit, well, this is globally speed and this is globally resistance. If you have an heavy, bulky boat, you'll see that the resistance will increase very, very rapidly. Meaning sometimes, if you take, for instance, something which 14 meter boat, you will see that if you want to sail 6-7 knots, you won't. The resistance is quite it's not too big, and then you don't need to have a very big engine. But if suddenly you want to go from 7 to 9 knots, which is not a big increase in percentage, for instance, then you would realize that you would need more than the double in power to reach this speed. And that's what we can see here, you know. And if you say in this part, the slope of the curve is quite doesn't increase too much, but here suddenly, I mean, for a little increase here, you would have a big increase in power. And here it's if you start to make light boat or planing boat or that kind of thing, then you see the curves are less less sloppy like that. They're more, it's more gentle, the increase in resistance. And to explain that, this is you know, the big the ferry on foils I showed you. If it was only a light catamaran, we would have a resistance curve like that, you know. This is a resistance, this is the speed. It would increase like that, a little bit like this one, in a way, huh? Some kind of thing. Having foils up to a certain speed, here, for instance, 23 knots, she will take off, she will take off and start to be foil borne. And then suddenly, the resistance decreases a lot. And, that's what I said, to go, for instance, at 35 knots, if the boat was only waterborne, like a traditional power catamaran, the resistance would be here, and being foil borne, it's less than half of the resistance, really. So that's, you can see here the interest of, of course, having a boat foiling, which of course minimize a lot the resistance and the water area in contact with water. And I think now I'm going to speak about the project. So if you have any question, I will be very happy to open the discussion.
I have a quick question about the chart on the right there. So is that saying, so when the boat isn't designed to go fast, but you wouldn't put foils on it because then it's creating more drag, and only when the boat's designed to go fast you would add foils. Is that correct?
Yes, it is correct.
Okay.
Foils, if you try to put, for instance, foils on a cargo ship, it will just add drag. It will not give you any benefit. There is a proportion between the weight you want to lift with the foil, which, remember, they are like wings, and the speed at which the boat operates. And heavy and slow boat, don't put foils, you will only add drag.
That makes sense.
Just one thing crossed my mind, that this wing with two elements, you can feel exactly what it is when I know it's not too often now, but when you're taking a plane, you see when landing you see the little tab
flaps
that extend and there's a slot between the main wing and the flap, and this is exactly the same phenomenon.
Okay. And do those get controlled manually, or is that always a mechanical system, or are they also controlled by like by people?
No, it's fully automated because for the for the maritime industry, we couldn't afford to have any any manual operation, or it could be even dangerous. I mean, so
Right.
it's better done. We have sensors that are measuring the wind speed and direction, and those sensors send the weather configuration to the computer, and in response, the computer will set the order to the control system to trim the sail to the right angle, and the flap to the right angle too.
Okay. Wow.
It's quite simple. In fact, it's very well. It's not. The principle is not really hard to understand. Doing it industrially is something else, but it's the principle is not very complicated.
Does it make sense to put that on cruising boats, or is it mostly again for racing boats and like
No,
large?
I dream to do. We are on the point to start a project like that, because it's you know, I mean, there are 9 powerboats sold for 1 sailing boat, and I don't think it's because people are really fuel lovers. It's just because or even speed lovers. I think it's just because learning how to sail, it's quite complicated, and I dream, with this wing, and maybe also with some automation, we could really make all that affordable, both financially and also technically, to people, to bring more people to. I mean, be nice if everybody could use the wind to sail on water.
Okay, that sounds awesome. Yeah.
So yeah, that's something we're gonna start to tackle, but maybe in 6 months, because at the moment we are deeply into producing the industrial shipping model. The wing,
Right.
the big one, are 363 square meter, 33 meter by 11. It's quite a big baby to, and it's pleasure. It's something, but talking to shipping, it has to work. If it goes wrong, you get into problems.
Mm-hmm.
But we will do so, and the big problem is not technical, is to develop a model that is affordable. And that comes with the number which are produced. And of course, when you start, you don't have hundreds pieces to build. You just so it also needs finance.
Yeah, that makes sense. Does anyone else have a question?
maybe I'll like to ask, when you design such boats, how much of it is made on engineered softwares that requires always to have direct feedbacks on the design? Is that a major part of the design process, or is there a lot to do as well with just your intuitions with the shapes you're modeling?
Even 30 years ago, it was fully intuition and drawing. Really, it was like that, and calculation by hand. Now, you're taking a reference boat. You're talking to the, well, speaking about, for instance, a racing monohull or racing multi-hull, you will talk and listen to the skipper to understand the way he sails, because it happened that we design based on the same hull 2 or 3 boats even for the same race, but depending on the sailor, on the skippers, the way they sail, maybe they want to have a level of performance which is medium. They say, I'm not going to be Superman for 70 days or 60 days. I may have up and downs, and so I want a boat which is not asking too much, which will have an high average speed, or you can have a skipper who say, I need to be good all the time, so I need a boat which is really demanding. And so it's not the same criteria, it's not the same power. And if you make a boat really powerful and you sail only at 60-70%, it will not be a good boat. I mean, the performance will not be there. So it's really, you have to listen, and then from that you set up the criteria, and you can run as much as solutions as you want. You have even developed in-house a dynamic modeler. I mean, you can test your boat on the screen. It's and with all the forces. Of course, it's not just a video game. It has all the reaction and all the forces. And so there's a little part of it, of course, intuition, listening, and to go in the right direction. But behind that, it's you can really go through I don't know, 20, 30, 40 different configuration and test them very, very quickly.
Okay, thank you.
But intuition is always there. I mean, if you are not in the right direction, you can test 30 bad solutions compared to the one you should have the right direction you should have tested first. It's otherwise everybody would do the same, would design the same boat. So still at the beginning there is this part of.
Yeah, because I was looking, for example, the America's Cup, and the 2 boats that were competing for a very short race, which is very competitive and intense. They had quite very different designs, and I was surprised in a way that they could came up with such different models of designs, even for such a short race, which is competitive and fast.
because probably at certain time one would think maybe I need to save, which is very important when I'm tacking or when maneuvering, and then you will probably work a little, trying to enhance the kind of performance in a special field, and the other one will try to something else. And those little, very, very little difference at 40 knots makes a huge difference at the end. But it's really nothing at this speed. I mean, the difference is almost nothing. So it's really impressive. But I don't know what, for the last America's Cup, I really wonder what the technology will bring to everybody. We'll see. They're strange boat.
I have a question I'm going to read from Anna Violette, since she can talk. It's in the chat. It says, I wondered more about the ecological aspects you talked about. There is always a concern about the boat being zero emission once it is built, but how did the construction of such boats adapt to this philosophy?
Yeah, it's a very good question. I think the life cycle analysis has to be really thorough. I mean, we can't. You could, for instance, decide to do a carbon boat, which of course is very bad in terms of construction, but that will be so light that it will save a lot of energy in service. But you know, it's always a question of knowing what you do and for what you do it. And looking at the pictures of those boats in Bangladesh, it is sure that if you decide to do a cruising catamaran, which is extremely simple, you know, ask yourself, you know, why do I want to be at sea? Is it to have the same comfort as I have at home? You know, because on cruising catamarans now you have a washing machine, you have everything you have at home. You have 4 cabins, 4 heads, 4 showers. I mean, it's more than what I have in my house. So do we need that, or do we go sailing for other reason? Do we want to be close to the sea and come back to nature? So those are the basic questions. If the answer is yes, then you don't need a lot, really. When I start sailing, we sailed with there was no comfort at all, you know. So, and we were very happy. I mean, it's so if you are in this, you know, if you think this way, I think the boat will be simple. Then it could be not built with very expensive or fossil sourced element like resin or carbon fibers or glass fibers, which are, you know, those fibers are asking a lot of energy to be produced. Then you can think it's going to be the purpose of the workshop. Maybe you can use natural fibers. Still, the resin is a problem, okay? But then if it's really light, then you won't need a lot in terms of propulsion to have a reasonable speed. and so forth. And with a solar panel, I mean, we can have a discussion about solar panels, but still, I mean, at the end, you can have a zero emission boat. But if it starts by asking yourself, why do I want to be at sea, and what kind of comfort, therefore, I really need? And everything is linked to that, in fact. But of course, and then you can have, I mean, the life cycle in operation of the boat is really good, because you're not using fossil energy, and for the build, if for instance you're using plywood or something like that, then it's okay too. I mean, you see what I mean. But then it doesn't look like the cruising catamarans I've just shown you at all. It's a kind of big evolution. But in a way, I mean, that's interesting. You know, it's like I've very often asking that to our client, I mean, yard clients. You know, the lagoon between the first one and the last one, the price and the comfort has always increased. Why that? It's because it's like the ostrich which has, you know, swallow a melon. It's demographically, it's the same population, which is just became older. Shows these, you know, they are richer, they want more comfort, but it's the same people. And what about the new generation? My kids, you, I don't know. Do we really want this? I'm putting myself in this batch. It's almost a philosophical question, which is, I think, fundamental, really.
Okay, thank you so much.
Does anybody else have any questions? I think Amish, yeah. Amish, do you have a question? Okay. I think everyone's here that's going to be in the workshop, so we could you could present the workshop now if you'd like.
Sorry, okay. Did you ask something?
Yeah.
Oh no, I just saw you pop up on the screen, and I'm not sure. I didn't know if you had a question or not.
Oh no. I mean, not yet. Let the whole thing maybe get over. I do have a question in mind, but maybe later. Maybe it will be answered in the explaining the workshop. So I'm just waiting for that.
But anyway, I think we're going to be together for some time, so
yeah.
I hope there will be some more questions.
Yes. I switched off my camera because I got a phone call, so sorry about that.
I have one more question quickly. So again, back to the foils, when is there a problem when there's like really large waves? Because like, does the foil lift the hull out of the water, but then is it like planar to it's not planar to the wave, it's more like planar to the surface. So then when the waves come, do they smash into the front of the boat like more than if the boat was just the hull and it's following the wave up and then it's going back down with it? Is that a problem, or does it not work that way?
Well, if the speed is such, the speed of those boats is such that you have to slow down, because the inertia of the boat doesn't, you know, you won't rise the bow soon enough. Then you would hit the wave, and
Okay.
honestly, there is no, I mean, those, especially the monohull we saw, for the one for the Vendée Globe, for instance, the IMOCA, they are, I mean, it's something which is, it's really noisy. It's shaking in all direction. People get hurt because they're thrown by the motion I mean, they leave, you know, like it's really I mean, you have to slow down. You will break something otherwise.
Okay, yeah, that makes sense.
Even the skipper. I mean, I always ask them, you know, that don't you think that maybe if we could look at some ergonomy, maybe some points of, I'm not talking about comfort, but, you know, being able to rest is very important, to have a clear mind. So maybe it would be good, even if it costs some weight, that you could, you know, have a better rest but no, they are totally. I mean, what same, you know, like 30, 40 years ago when you were looking at the boat we designed. I mean, I could project myself and say, well, I could, you know, I could do that. I could go and race on the boat I have designed. But nowadays, it's absolutely not the case. I would not be able to go 2 miles away on the boat we designed. I think it's the same in Formula One, the Formula One engineers. I'm not sure they're able to go to do 1 lap around the Formula One track. I'm not sure they can drive the car, but I'm certainly sure that I won't be able to sail on this. We perfectly understand, of course, intellectually what we're doing, of course, but it's another world. I mean, being at 40, 45 knots on the water, it's something really strange.
All right, thank you.